Now I'm doing another video for DC amplifier. So I'm going to remove this one. Okay. So this is the circuit. It's the same amplifier. Then what I will have is actually two resistors here and two resistors down. And then I have VCC and the ground. Okay. So I already have the ground. I can go to source and find DC. For example, VCC, VDD does not matter. I'll use the same name. And then I'll have resistors, four of them. Take any value and just you can copy and paste, change the values later. Okay. So I can also have two grounds just to make it easy looking. Okay. And then I'll have this one here. I think this is 50K value. Okay. And here, this is 22K. And here, 2.2K. And here, 3.3K. Okay. In your case here, put please 15 volt. So 15 volt. Okay. I'm going to change it here. I'll keep it actually 25. Please follow the circuit that you have in the lab. So this should be actually 15. Huh? I'm going to do it only 25 for demonstration so that you don't take actually my values. Okay. So here you have two choices. You either build the whole circuit, which I don't recommend, or first start with the DC analysis because it will not affect, and then you add the other components. So for this case, you have you can either use the multimeter or there is something called voltage and current indicator. So if you look here, that's a voltage. Okay. The voltage indicator will be from a point to the ground. Okay. Usually, if you remember, the multimeter has two terminals. So the other terminal is the ground. So here I'll put one here, for example. Okay. I'll put one here and I'll put one here. All right. Let me just try to simulate just to see if there is a problem. Okay. So what I need to do here, because I stopped, I did not actually change the simulation parameters. So cancel. All right. Go to simulation, make it interactive simulation. Okay. And then run. So I think there is a problem here. Okay, this is the DC. It's fine. 15 point something. And then here you'll have another DC value. So this is 7.36.67. Your case, this will be another value. So what you can do, you can put this one here, put this one here, put this one here. So I'm okay. Then I can have a current indicator. Now for the current indicator, if you have, let's say, a resistor, let me just have any resistor. The current indicator, it's actually measuring the current entering into a terminal. So you have to put it either this way. So to measure the current going here, or you put it this way, it will measure the current going on the other direction. Okay. So I'm going to use it now. You can put two of them. Of course, طبعا, you can have some space here. Okay, I need to measure, this is actually the current. Okay, and then I have another one, which is actually entering this terminal, right? Okay, so you can see the arrow here, and then I have another one. Okay, let me also run it. So please try to see which current is which one. You can see that there is an indicator. That's another current. So it's up to you. Either give one picture where you have the voltages. This one should be here. Okay, so this will give you V of the base, the collector, and the emitter, and so on. You can take the values, just take a snapshot of this one, just to stop this one, take a value. I don't care about the frequency here because it does not make sense for me. Just look at the values, take a snapshot, okay? And you can verify your currents by taking, for example, 25 minus this voltage divided by this one. It will give you this current, right? Okay. Now what I will do, I'll continue. So I'm not going to do the simulation for you totally. So I will add a capacitor. Then add a resistor. So let me have three capacitor. Then you go to sources. Okay, this is voltage source. Okay. So you need to set up the values, the value of this one, whatever you have added, the value of the peak and the frequency and so on, the capacitor values also. And then I'm going to look at the Tektronix oscilloscope. So as I told you before, I have this one to be connected to the ground. Okay, I can have channel one to the source directly, right? And then channel two, I can take it to VS2. And then channel three is going to be to the output here, okay? And then you can run the analysis and look at your values here. Turn it on. Show all of the three together. Okay, and then just do some adjustment to see the peak-to-peak value. You can go to measure and find the peak-to-peak of each one and take a snapshot of this. So you will have to do this one, for example, with everything connected, then you're going to remove this one. And then at the end, you're going to remove this one. Now, if you move this one, okay, I hope it works. That's fine. Sometimes it gives an error that actually if you remove this one, there is something open because the capacitor. So what I can do, I remove the capacitor connected directly here. But it's okay. Yeah, if it is working, then it's fine. Please do this circuit. It's not difficult. What you need to do is first you do the three peak to peak with everything connected. Then you're going to remove this one and then return it and then remove the RL and you complete the table. So you have actually three tables here. Actually, this one, I mean simulation 1, 2, 3. Then you need to find RN and R out using simulation values. Okay. Thank you very much.